Hey guys, this is Lego Master 99 here today, and today I am back in the Redstone Computer version 3.0 world here, and you guys might be wondering, why is he back in this world? Didn't he already make a video on this? And yes, I did. And I'm here because I want to present something new today to you guys, and I'll give you a scenario here. Let's say you watched my Redstone Computer 3.0 video or my Redstone Computer 4.0 video, then the updated version of this computer. Then I'll put links to both of those in the description. But anyway, let's say you watched those and you wanted to program it, see how versatile this computer is, see how you could manipulate these cores and do operations and that kind of thing. But you don't want to watch the hour to hour and a half long tutorials that I put out, and those were very long tutorials, or programming guides on what every single opcode means if you're talking about like operations and conditions and stuff and blah blah blah. And you don't want to do that, but you still want to program this computer and you still want to test it and play around with it and that kind of thing. So what do? So up until now you haven't had any other option. That's been your only option. But today I present to you another solution to that problem. Alright, so that solution is in the form of another program. So if I go ahead and just exit out of here and pull up another program I have here, as you can see here, it's very rudimentary, but as you can see, it is a core compiler. Now, or not just a core compiler, it's a compiler. And yeah, basically this other solution I'm talking about is indeed a compiler, as you guys may or may not have guessed. So if you guys are not literate in computer science, basically what a compiler is that it'll basically I guess translate or it'll convert one language to another language, or in this case it'll convert some language to binary for us to be able to run programs on these Redstone computers that I made. So this compiler here exists because it's basically it allows you to write programs in a proprietary language, and then you're able to compile those into binary or machine code, which then you can basically copy into these program memory here, these program memory slots, so that you'll be able to basically write your own program and then upload it to the computer and then just run it straight off without needing to know how each of the flags works, how the opcodes work, how all the binary works here, and all the operations, how that all works. All you need to worry about with this new solution that I'm presenting you, this compiler here, is the language, and it's basically whatever you want. So you just write your own program in the language that I'll be talking about in a minute, and I'll be going in more depth into that in just a minute. And you'll be able to basically write your own programs and upload them to this computer, as well as any other computers, such as my Redstone Computer version 4.0 and maybe upcoming projects, maybe we'll see. And yeah, so I'm really excited to finally show this to you guys. Although it is very rudimentary, it's still a very active project for me. It's been a very interesting project for me. So yeah, I guess I'll just show you some examples of this program running in action for you guys. So to be able to better explain what this whole compiler thing is, what this whole language thing is, I guess I will start with the Redstone Computer version 4.0 notes. Now you can find this in the Redstone Computer 4.0 world download, and it's called Redstone Computer version 4.0.txt. And in here, if you look, it says right here, custom instruction set, and then it says here, runs AGuyWhoIsBored's Redstone Computer instruction set specification version 1.0. Now, this here, when the video came out, you guys may have thought, oh, it's just a fancy name for all this binary here and the way this whole thing works. But in reality, what this refers to is the language that this compiler supports right here. And it's the language that this compiler supports, and it's the language that this Redstone Computer 3.0 and the Redstone Computer 4.0, that's the language that both of those run on, although of course the Redstone Computer 4.0 has more features and functions, and we'll get into that later. So I call those Arcus for short, ARCISS. And here is the official language documentation for it that I came up with when I started this. And as you can see, this was created on the 21st of June on 2016, which was a while ago. And basically this project that I'm now showing you guys has been in development for a very long time. Although it's still very much not stable yet, and it's still in development, but it's stable enough for me to show it to you guys, and that's what I'm excited about. So this language is AGuyWhoIsBored's Redstone Computer instruction set Spec version 1.0, and as you can see here, Arcus, or if you want to name this whole thing, it's just ARCISS with two S's. As you can see here in the compiler, it says core compiler and then supports Arcus Spec version 1.0. So when I'm talking about version 1.0, I'm talking about this right here. And now this basically documents all the functions you can run in this language, the way the language works. And yeah, basically this compiler supports a proprietary language called Arcus, for recap, that I have gone ahead and created here, and the documentation is all here. So then as you can see, we have this is Spec 1.0, and then as you can see up here, this is the version 1.0 of the instruction set. Currently 2 Redstone computers are supported by the Spec, version 3.0 and version 4.0. And basically you can read through this. I will put a download link to this in the description so that you guys can read through this. But basically it's like your everyday C#, C++. It's one of those languages, except it's not as high level, but it's still a couple levels higher than this binary, which the Redstone Computer version 3.0 and at the Redstone Computer version 4.0 manipulate with, control. The way it's the architecture behind them. So yeah, that is the language that this compiler supports and that these two computers support. And now I guess I will show you a program in this language, and I will show you guys how it works, what it does, all that good stuff. Right, so here is a program that I have loaded up here. Now this is a Fibonacci sequence program. See here, runs the Fibonacci sequence, and this is basically the program that ran on the Redstone Computer 3.0 showcase video. And the Redstone Computer 4.0 showcase when I was doing the comparisons. This is the Arcus, remember, custom instruction set here, the Arcus representation of that program written out. And before I forget, I also wanted to mention that this compiler is called the drchll-c. It's an acronym for Duncan's Redstone Computer High-Level Language Compiler. And yeah, I just want to let you guys know in case this drchll-c comes up anymore, so you guys know what that means. So anyway, here is what this looks like. Now, I also came up with some formatting rules. As you can see, I'm running Notepad++. So let's go ahead and load the formatting. So now it looks a lot better and a lot more like a language. So here, as you can see, it works a lot like your regular programming languages do. So you have variable initialization here, you have loops, you have if statements, functions, all that kind of thing. And yeah, this is just an example here, and I will go ahead and I'll explain what this does. So basically, here, this is initialization. It creates 2 new variables, and then this is the tag for a loop to start a loop here, as it's commented here. And basically, this checks if you add the 2 values, it causes this thing called a shift overflow, which if you guys watch the Redstone Computer 3.0, Redstone Computer 4.0 videos, it's basically when the number is bigger than 255, which is the 8-bit limit, then it'll exit. As you can see, it's a function. It needs brackets and everything, so it's a lot more higher level than binary or assembly or that kind of thing, which is really nice and makes it really easy for programmers like me and other people to utilize these computers as an actual programming target. It makes it a lot easier. This is like the bridge between the across the problems for that. And then here, as you can see, we have an else statement. Then it'll you have value 1 equals value 1 plus value 2, so we're adding them over and over again. And then you have an output function which outputs it to the display. And then I'll go in depth with more of the syntax later and stuff. And then basically does that again, and then as you can see here at the very end, it jumps back up to here, which is main loop. So it's named main loops. That's a very short description of the program, how it works, and that kind of thing. And now I will show you, now that we have a program here, now that we have a program here, I'm going to show you guys it being compiled, and I will show it being uploaded to the computer. And a couple more things. If you're writing a program, I'll go into more depth in this later. As you can see, we have a hashtag? No, not hashtag. # RC compile target. Now this is needed to make sure the compiler recognizes that this is a valid file to be able to program or to compile. And then as you can see here, we're importing extensions and stuff. Now I will get into that later, and now I will show you guys this program being compiled. So now I'm going to show you guys the compiler running in action, and I'm going to show you guys this program being compiled here into machine code for the Redstone Computer 3.0 here. We're going to run a test with that program on the Redstone Computer 3.0 when we're done, just to show you that it works. So we have our program here, and we have the compiler window here. Now this is not the final revision of the compiler, and it looks like my desktop background has changed. But anyways, this is not the final revision of the compiler, and it looks like this just because it's a lot easier for me to worry about the back end and how the actual compiler works, other than worrying about the GUI and buttons and that kind of thing. So anyway, what we're going to go ahead and do is pass in the arguments needed to compile this. So I'm going to go ahead and reference this file here, since this is a program, as you can see. That's on my desktop, and then RC Fibonacci program for showcase.txt, and then go ahead and select core 1 and select the Redstone Computer 3.0. And now if we hit enter, as you can see here, we get some output here, and then as you can see, a new file was created here. And we can go ahead and hit enter here, and as you can see, compilation complete. It took about 2.5 seconds, and 12 lines of machine code were generated for the compiler target. It was exported to this program binary file, or PB. You can press enter to exit out of the compiler. Now as you can see here, it generated this file. Now if I go ahead and open this file, as you can see, it is just straight ones and zeros. It is machine code, and this is the representation of this program in machine code here. And you would want to copy this into your program memory here for this program to be able to run on the Redstone Computer 3.0. And however, this only works on core 1, as my current 2 compiler targets, which that's what I call my Redstone computers, the Redstone Computer 3.0 and 4.0, have the unique quad core design. So the instructions are actually a little bit different for each core, so make sure you guys keep that in mind when compiling. And I will put some documentation and stuff in the download that you guys can find in the description later. So that'll help you write programs. So as you can see, we have our machine code here, and yeah, that is the compiler working in action. Alright, so now the next question you may be asking is, how in the world do you take this and put it in here, just like quote unquote copy it, I guess you can say. Since we have our program here, we have it translated into machine code, but now how do we put it in Minecraft to actually run? And I have an answer to that as well. So if we go ahead and go over here for a second and launch this, as you can see here, I have another program here, and this is the solution, and it is a machine code uploader. Now this program is basically what it sounds like. It's an uploader, and what it'll do is that it'll go ahead and upload this machine code to either the Redstone Computer 3.0 or the Redstone Computer 4.0. And excuse me, that was a very interesting program to write, and this program will allow you to make it a lot easier to be able to program. So all you have to do now with the compiler and machine code uploader, and again, the machine code uploader is very bare bones, since I want to worry about the infrastructure and the back end and that kind of thing. But now what all you'll have to do is write your program in Arcus, and then use the compiler to convert it into machine code, and then use the uploader to upload that machine code to whatever compiler target you want. And it's a lot simpler than watching my albeit pretty complicating tutorial videos on how to actually program this computer and then deal with all the opcodes and stuff and deal with like debugging and that kind of thing. Well, you'll still have to deal with debugging when you're working with any program, but you won't have to worry about the bits and this very nitty-gritty stuff, as the compiler takes care of that for you automatically when you write in Arcus. And yeah, I think it's a pretty revolutionary thing, I'd say. So that instead of programming in binary, you'll now need to program in Arcus, and you'll only need a couple external programs to be able to compile and write your own programs for these computers. And I think I've been babbling on long enough, so I guess I will show you guys a working demo of this uploader in action. So since this program is able to be uploaded to both the Redstone Computer 3.0 and the Redstone Computer 4.0, or uploaded and compiled for both of those targets, I will show this program being uploaded and compiled, or compiled and uploaded, sorry, for both of those targets. But first, let's start off with the Redstone Computer 3.0. So I'm going to go ahead and start up my uploader program here. So you'll need this to be able to upload. And what you'll need to upload is basically your Minecraft, your uploader, and this is basically a very general instruction, I guess, very general tutorial on how to upload, but this is just a showcase. This will change as time goes on. And then you need this file right here that the compiler generated. So what we're going to go ahead and do is specify that file that we want to, or the machine code program that we generated, which is this .program binary, the PB file right there. Oops, not showcase, there we go. And then I'm specifying debug mode, and then I'm specifying that I want to upload to the first core, and then I want to upload to the first target, which is the Redstone Computer 3.0, and that's the compiler target. And then I'm going to set some options for myself. And now I'm going to go ahead and press enter to begin upload, and now as you can see, we have to wait for 10 seconds. But if we wait for 10 seconds, we will see that it'll spring into life. Alright, there we go. So now as you can see, the uploader is taking control of the Minecraft window here, and it's now clearing the selected core program memory, which basically means that, it's emptying that memory so that we'll be able to write a new program into this. And as you can see on the uploader on the left, we have a indicator there, and as you can see, it's now uploading the program to the core, which is very good. And as you can see, we have a progress indicator on the left side. And now basically what it'll do is that it'll go ahead and place redstone torches for every single one that's in the machine code, and it'll do that so that you don't have to do it yourself. You don't have to worry about it. The uploader does it entirely for you. All you have to do is just wait for it to finish. As you can see, it's almost halfway done. And after this finishes, I'll go ahead and show you the program that this uploader just uploaded running, and hopefully it'll be the same program that we went ahead and wrote in the Arcus language. It should be, and yeah, I'm planning on adding a lot of new features, additional features such as optimizations, extensions, cross-compatibility support, or cross-OS support, since this compiler only supports Windows at the moment. So yeah, I'll be working on that. But then as you can see, the upload just finished, and it took not even a minute and a half to upload and clear the entire thing. And now as you can see, it has gone ahead and placed redstone torches here in this program memory for us, so that we do not have to do it. And that's what the uploader does. It's the bridge between our machine code here and the in-game program memory. And now that that's done, I guess we'll just go ahead and run the program and see what happens. Alright, so now I'm up here in the control panel for the Redstone Computer 3.0, and we are ready to test the program that we had just compiled. Now, before I go ahead and start the program, I want to let you guys know that the uploader is not a fully bug-free program yet, because as you saw, or as you may have seen during the upload clip, there was an upload error that occurred. If you saw that when the redstone block here was switched out with the gold ore, whenever that happened, but it happened right around here. So that happens sometimes, and it's still a small bug to fix, but the uploader still mainly works, and I've gone ahead and tested the program, and it still works fine. So let's go ahead and teleport back up here. So I just wanted to Just wanted to let you know that this program, that is an example of the fact that these programs that I'm developing are still very much programs in development, and they're not completely bug-free yet. But anyways, nonetheless, let's go ahead and run our program. So I'm going to go ahead and leave that off and then run it at 50 ticks. So we'll go ahead and turn the computer on. And this is a Fibonacci program. As we saw in the uploader, as we compiled and uploaded it, this is a program that'll run the Fibonacci sequence, which basically is adding each number to the numbers before it. So then you would have 0, then you start off with 0, and then plus 1, and then 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, so on and so forth. And if we just let this run, as you can see, the program counter here is working fine. Line of code for code 1, so this is working. And if we wait here for just a second, as you can see, our first value of 1 just came up on the screen, which is a pretty good indicator for the fact that this program was uploaded and compiled correctly for this core, for this compile target, and that the whole thing works, and that I'm not just lying to you guys, since that took almost half a year, or more, actually more than half a year to design and develop, and it's not even close to done yet. So, but it's coming along very well, and I wanted to show you guys. So yeah, I'm very excited to show you guys this right now. But anyway, if we continue to wait for a second, I think the next value will be pushed out to the screen here in just a second. If we wait, as you can see, okay, there you go. So there's the next value, which is 2, and then the one after that will be 3, and then 5, and then so on and so forth. And I think I'm going to go ahead and time-lapse the program running for you guys to show you guys that it is really running the Fibonacci sequence. So I will meet you guys near the end of the program. Okay, alright, so the end of the program is coming near. I'm going to go ahead and shut off or put the computer to sleep. And let's wait for the computer to go to sleep as the chunks go down or the chunk updates go down. Okay, so now we're going to go ahead. Jeez, I'm tripping all over my words. And change the clock speed, since for some reason on the Redstone Computer 3.0 it's an architectural limit, but you have to run the computer at a slower speed when you're doing shift overflow, shift underflow conditions, that kind of thing. And this is the shift overflow condition that'll shut off this program. So if we go ahead and resume the program, it should go ahead and hit 233 and then hit a shift overflow and then shut off. And as you saw, okay, so there's 233. And as you saw, the program successfully ran through most of the Fibonacci sequence, and then there's our shift overflow right there. Our shift overflow lamp is turned on. So it successfully ran through the Fibonacci sequence, and the program should shut off in just a second here if we go ahead and wait. But anyways, it went ahead and successfully ran the Fibonacci sequence. Oh, is the computer off now? Okay, I think the computer is off. Yeah, the computer's off, but it's not resetting because we deselected this clear RAM and UI outputs on shutdown. So the computer shut off successfully, and yeah, so that just about goes to show that the compiler does work and that the Arcus language is supported by these computers and that kind of thing, as we just ran a program written in the Arcus language that works for the Redstone Computer 3.0. And now, yeah, I guess I'll show you guys this same thing working for the Redstone Computer version 4.0. So I am in the Redstone Computer version 4.0 world here, and I'm going to show you guys the same program here, the Fibonacci program written in the Arcus language, being compiled to the Redstone Computer 4.0 and being uploaded and ran on the Redstone Computer 4.0. Now, a thing to know with the Redstone Computer 4.0 is that this computer has some new functions and stuff and some new capabilities that are not on the Redstone Computer 3.0. And so to fully utilize those capabilities, mainly the use of this giant screen right here, if you noticed in our program, we have this line here that says import RC40E. Now this stands for Redstone Computer version 4.0 extension, and this is basically an internal compiler extension that allows us to use all of those commands and that kind of thing, but I'll go in depth into that in another video. But basically this program here doesn't use any of those new extension functions and that kind of thing, so we can basically upload this program to both the Redstone Computer 3.0 and the Redstone Computer 4.0 at the same time. Or, yeah, at the same time basically. And at the moment, this will be added later, but another thing is that this computer, or the compiler rather, doesn't support the caching that this Redstone Computer 4.0 has built in right here, like this this lime wool section, and it's baked into the ALUs and stuff. The compiler does not support that yet, but it will. And as I was saying, this is still a program very much in development. So to go ahead and compile for the Redstone Computer 4.0, I'm going to go ahead and pull up my compiler here. And we're basically going to do the same thing we did last time. So we have our program here, right? And it's located right here on my desktop. So we're going to go ahead and load that in. And then we're going to go ahead and upload to core 1 again, but now what will change is that we're uploading to the second compiler target, so that is the Redstone Computer 4.0. And so we will just leave it like that, and now if we just wait, as you can see, it went ahead and compiled. And you know what, we should probably do that again. Well, it basically overwrote this program binary file, and I'll show you guys in a second. Then as you guys can see, it finished the compilation about 2.5 seconds again, the same time as it took the Redstone Computer 3.0 compilation. We can go ahead and close that out. And as you can see here, we now have a program binary file. Well, it was the same program binary file, just overwritten. As you can see, it's been modified, and we'll reload it. And now, as you can see, we have totally different machine code in here. And the reason for that is because the compiler knew, or we specified that we were compiling for the Redstone Computer 4.0. Now, the Redstone Computer 4.0 has a much bigger instruction set physically than the Redstone Computer 3.0, and as you can see, we can clearly see that here. So yeah, this is the compiled machine code for the Redstone Computer 4.0, and now we will go ahead and upload it to this compiler target. So to go ahead and upload the program binary file that was just compiled, what we're going to go ahead and do is launch the uploader, and go ahead and wait for a second. It's taking a little bit longer. Okay, there we go. So here's the uploader, and we need to go ahead and have our Minecraft window to the side here. And now what we're going to go ahead and do is do the same thing we did with the last Redstone Computer uploading, where we just, not RC40, Fibonacci program that. We're basically going to load in our program binary file. I'm going to toggle debug mode. We're going to select the first core to upload to, this second compiler target to upload to, and then turn on some options. And I'll go ahead and wait, and as you can see, it's going to upload in 10 seconds. And now you should probably watch out and see if the program corrupts anything. We will see, but as you can see, it's now going ahead and clearing the program memory, and as you can see, there was some leftover data on the program, or in the program memory for the Redstone Computer 4.0, the first core of it. Now, as you can see, it's going to take a little bit longer to clear the selected program, the core program memory on the left, as you can see, because obviously the Redstone Computer 4.0's program memory is larger and takes a longer time to clear out. And those options I toggled, if you look in the console on the left, it says clean first is enabled and fast upload is enabled, so that we don't, because usually the upload process takes a really long time, but I have fast upload enabled so that it won't take a while, so that I don't need to have you guys sit through like an hour of like uploading. But then as you guys can see, it went ahead and cleared some more data from the program memory, and it's almost 75% complete. And I guess we will go ahead and wait for this to finish. Alright, so the uploader, or the cleaning of the core is just finished. Now as you can see, it's uploading the program here, and hopefully this won't take too long. Excuse me. But yeah, hopefully this won't take too long, since it usually takes a little bit longer on the Redstone Computer 4.0 than it does with 3.0. As you can see, it's taking a little bit longer, but yeah, this uploader supports both. It'll support all my Redstone computers that I'll ever make, or I'll at least hopefully update it so that that will be the case. And the compiler will also support all of the Redstone computers that I'll ever make, and it'll be, I think, it was a really fun project for me to work on, just because it was very interesting and that kind of thing. So yeah, I guess we'll just go ahead and hope that the uploader doesn't bug out again like it did in the Redstone Computer 3.0, where I had to manually fix it. But yeah, we'll just go ahead. I'll go ahead and meet you guys back when this is done uploading. Alright, so as you can see, the upload has finished, and it took a little bit longer, 152 seconds. I can't do the math in my head for how many minutes that is, but it finished uploading to this Redstone Computer 4.0. And yeah, now let's go ahead and run part of the program and see if it works on this Redstone computer. Alright, so we are here in the Redstone Computer 4.0, and I've gone ahead and set this Core 1 to be enabled, and I've gone ahead and set the speed to 50 ticks here. Now if we go ahead and start the program, and we give it a second, it should, or like a minute or something, the number 1 should come up, and then it'll basically do the same thing that the Redstone Computer 3.0 did, which will go 1, 2, 3, 5, 8, 13, 21, 34, that sequence. And yeah, I'll just go ahead and meet you guys back near the end of the program, and we will see what it does. Okay, as you guys can see, it has gone ahead and printed out the first number here, which is a 1, which is basically means that the program is working. At least I hope it is, or it looks like it's initially working, because the first number it's printed out is 1, and then it's 2, and then it's 3, as I said earlier. So yeah, let's hope that... Alright, let's take a look here. Alright, let's hope that the next number that'll come out will be a 2, and then after that I'll just go ahead and speed this up so that we'll be able to see the result, or near the end of the program, or the results of it, so that we'll be able to determine whether the compiler compiled properly or not. And as you can see, 2 came out, so I'm pretty confident that the compiler worked the way it's supposed to, but I'm going to go ahead and let this program go through most of its cycles, and then I'll meet you guys back. Okay, so as you guys can see, just from running that little anecdote of the program, we can see that the compiler did do its job, and it compiled for this Redstone Computer version 4.0, and I went ahead and ran the program, mostly, but we just wanted to run a small test, and that small test worked successfully. So yeah, now that we know that the compiler worked, I just wanted to show you guys a couple of examples of programs running on it, like real case scenarios, that kind of thing. So yeah, I think that is basically all I have to talk about, at least for an introduction to this compiler, to the uploader, to my whole project on that, and the whole thing. Alright, so I think that's going to be it for this video. Thank you guys so much for watching this video. I'm really excited to finally release this, or not release, at least let the world know about this compiler project, and it's been under the wraps for quite a while. And yeah, I'd like to thank Lawrence Waynes. I think I apologize if I butchered your name, but credits to him for inspiring me to work on a compiler like that, because I think he is the only other YouTuber that I know that has a Minecraft compiler to compile for his Redstone computers that he made, the Red Game series, the infamous Red Games. So yeah, thank you guys so much for watching this video. I plan on releasing more content for this compiler in the future, so if you guys want any special content, just let me know in the comments below. Let me know about your feedback on this compiler in the comments below. And yeah, thank you guys so much. Until next time, guys, see you later. Bye bye.